The Lockheed Martin F-35 Lightning II is an American family of single-seat, single-engine, all-weather stealth multi-role combat aircraft that is intended to perform both air superiority and strike missions. It is also able to provide electronic warfare and intelligence, surveillance, and reconnaissance capabilities. Lockheed Martin is the prime F-35 contractor, with principal partners Northrop Grumman and BAE Systems. The aircraft has three main variants: the conventional takeoff and landing (CTOL) F-35A, the short takeoff and vertical landing (STOVL) F-35B, and the carrier-based F-35C. The F-35 first flew in 2006 and entered service with the U.S. Marine Corps F-35B in July 2015. Followed by the U.S. Air Force F-35A in August 2016 and the U.S. Navy F-35C in February 2019. The aircraft was first used in combat in 2018 by the Israel Air Force. The U.S. plans to buy 24 56 F-35s through 2044, which will represent the bulk of the crewed tactical aviation of the U.S. Air Force, Navy, and Marine Corps for several decades. The aircraft is planned to be a cornerstone of NATO and U.S. allied air power and to operate until 2070. Like the F-22, the F-35 has been targeted by cyber attacks and technology theft efforts, as well as potential vulnerabilities in the integrity of the supply chain. The F-35 is expected to be continually upgraded over its lifetime. The first upgrade program, called Continuous Capability Development and Delivery, C2D2, began in 2019 and is currently planned to run to 2024. The near-term development priority of C2D2 is Block 4, which would integrate additional weapons, including those unique to international customers, refresh the avionics, improve ESM capabilities, and add remotely operated video-enhanced receiver support. C2D2 also places greater emphasis on agile software development to enable quicker releases. In 2018, the Air Force Life Cycle Management Center awarded contracts to General Electric and Pratt & Whitney to develop more powerful and efficient adaptive cycle engines for potential application in the F-35, leveraging the research done under the Adaptive Engine Transition Program in 2022. The F-35 Adaptive Engine Replacement Program was launched to integrate adaptive cycle engines into the aircraft by 2028. The F-35 is the second fifth-generation fighter to enter U.S. service and the first operational supersonic stealth fighter. The F-35 emphasizes low observables, advanced avionics and sensor fusion that enable a high level of situational awareness and long-range lethality. The United States Air Force considers the aircraft its primary strike fighter for conducting suppression of enemy air defense missions, owing to the advanced sensors and mission systems. The F-35 has a wingtail configuration with two vertical stabilizers canted for stealth. Flight control surfaces include leading-edge flaps, flaperons, rudders, and all-moving horizontal tails or stabilators. Leading-edge root extensions or chins also run forwards to the inlets. The F-35 is considerably heavier than the lightweight fighters it replaces, with the lightest variant having an empty weight of 29,300 pounds or 13,300 kilograms. Much of the weight can be attributed to the internal weapons bays and the extensive avionics carried. While lacking the top speed of the larger twin-engine F-22, the F-35 is competitive with fourth-generation fighters such as the F-16 and F-A-18, especially when they carry weapons because the F-35's internal weapons bay eliminates drag from external stores. All variants have a top speed of Mach 1.6, attainable with full internal payload. The powerful F-135 engine gives good subsonic acceleration and energy, with supersonic dash and afterburner. The large stabilators, leading-edge extensions and flaps, and canted rudders provide excellent high alpha or angle of attack characteristics, with a trimmed alpha of 50 degrees. Relaxed stability and triplex redundant fly-by-wire controls provide excellent handling qualities and departure resistance. Having over double the F-16's internal fuel, the F-35 has a considerably greater combat radius, while stealth also enables a more efficient mission flight profile. The F-35's mission systems are among the most complex aspects of the aircraft. The avionics and sensor fusion are designed to enhance the pilot's situational awareness and command and control capabilities and facilitate network-centric warfare. Key sensors include the Northrop Grumman APG-81 active electronically scanned array radar, BAE Systems ANASQ-239 Barracuda Electronic Warfare System, Northrop Grumman Raytheon Electro-Optical Distributed Aperture System, Lockheed Martin Electro-Optical Targeting System and Northrop Grumman Communications, Navigation, and Identification Suite. The F-35 was designed with sensor intercommunication to provide a cohesive image of the local battle space and availability for any possible use in combination with one another. For example, the APG-81 radar also acts as a part of the electronic warfare system. Much of the F-35 software was developed in C and C++ programming languages, while a DA code from the F-22 was also used. The Block 3F software has 8.6 million lines of code. The mission system software, particularly for sensor fusion, was one of the program's most difficult parts and responsible for substantial program delays. The F-35 was designed from the outset to incorporate improved processors, sensors, and software enhancements over its lifespan. Technology refresh, which includes a new core processor and a new cockpit display, is planned for Lot 15 aircraft. The USAF has studied the potential for the F-35 to orchestrate attacks by unmanned combat aerial vehicles, UCAV, via its sensors and communications equipment. Stealth is a key aspect of the F-35's design, and radar cross-section, RCS, is minimized through careful shaping of the airframe and the use of radar-absorbent materials, RAM. Visible measures to reduce RCS include alignment of edges, serration of skin panels, and the masking of the engine face and turbine. Additionally, the F-35's diverterless supersonic inlet, DSI, uses a compression bump and forward-swept cowl rather than a splitter gap or bleed system to divert the boundary layer away from the inlet duct, eliminating the diverter cavity and further reducing radar signature. The RCS of the F-35 has been characterized as lower than a metal golf ball at certain frequencies and angles. In some conditions, the F-35 compares favorably to the F-22 in stealth. For maintainability, the F-35's stealth design took lessons learned from prior stealth aircraft such as the F-22. The F-35's radar-absorbent fiber mat skin is more durable and requires less maintenance than older topcoats. The aircraft also has reduced infrared and visual signatures as well as strict controls of radio frequency emitters to prevent their detection. The F-35's stealth design is primarily focused on high-frequency X-band wavelengths. Low-frequency radars can spot stealthy aircraft due to Rayleigh scattering, but such radars are also conspicuous, susceptible to clutter, and lack precision. To disguise its RCS, the aircraft can mount 4 Lunabird lens reflectors. To preserve its stealth shaping, the F-35 has 2 internal weapons bays each with 2 weapon stations. The 2 outboard weapon stations each can carry ordnance up to 2,500 pounds, or 1,100 kilograms, and 1,500 pounds, or 680 kilograms, for the F-35B, while the 2 inboard stations carry air-to-air missiles. Air-to-surface weapons for the outboard station include the Joint Direct Attack Munition, Paveway series of bombs, Joint Standoff Weapon, and Cluster Munitions, or Wind-Corrected Munitions Dispenser. The station can also carry multiple smaller munitions such as the GBU-39 Small Diameter Bombs, SDB, and Spear-3, up to 4 SDB can be carried per station for the F-35A and F-35C, and 3 for the F-35B. The inboard station can carry the Advanced Medium-Range Air-to-Air Missile and eventually the Joint Advanced Tactical Missile. 2 compartments behind the weapons bays contain flares, chaff, and towed decoys. The aircraft can use 6 external weapon stations for missions that do not require stealth. Nuclear weapons delivery via internal carriage of the B-61 nuclear bomb is planned for Block 4B in 2024. Both hypersonic missiles and direct energy weapons such as solid-state laser are currently being considered as future upgrades. Lockheed Martin is studying integrating a fiber laser that uses spectral beam combining multiple individual laser modules into a single high-power beam, which can be scaled to various levels.